Okay, this is a question. Figure shows two blocks in contact sliding down an inclined surface of inclination 30 degree. The friction coefficient between the block of mass 2 kg and the incline is mu1, and that between the block of mass 4 kg and incline is mu2. Calculate the acceleration of the 2 kg block if mu1 is this, mu2 is this. Okay, so let us see this. First we'll say A. So in A, which is 1 and which is 2? So the friction coefficient between 0.2 is mu1. So this is mu1 is here and mu2 is here. Okay. So in first case, mu1 is given 0.2. So mu1 is 0.2 and mu2 is 0.3. So what does it mean? It means that mu1 is having less friction. So it will have larger acceleration if these two objects are kept separately on the two surfaces. Then this object will have larger acceleration. The acceleration which we write generally is how much? G sin theta minus mu cos theta. This is the acceleration of an object kept on an incline of inclination theta and coefficient of friction mu. You can see that if mu is less, the acceleration is more. So for 2 kg object, the surface is smoother. Surface is smoother, it is less. So 2 kg tend to have larger acceleration, but this object has rougher surface, so it will have less acceleration. But you can see that 2 kg object is above the 4 kg object, so it cannot cross the 4 kg object. Since the 2 kg is above 4, it cannot cross it. Okay, so they have to move together. They have to move together. If the 2 kg was below 4 kg, the 2 kg would have slided faster and they would have separated. But in this case, they will not separate because 2 is above 4 and 4 is on the rougher surface. So they will move together. So 2 kg and 4 kg moves together. Two kg tend to move faster. 2 kg tend to move faster, but tend to move faster. 2 kg tend to move faster, but they move together because 2 kg is above 4 kg. Okay. Now, if they are together, we can write the combined equation. So writing combined equation for 2 kg and 4 kg. Okay. So what are the different forces? So this is suppose M1. 2 kg is M1 and 4 kg is M2. Okay. So what are the different forces? First, we make the free body diagram. If you make the free body diagram, it is 2 kg, that is M1g, then 4 kg is M2g, then normal. Both the objects will have normal. The N1 for mass 1 and N2 for mass 2. So N1 and N2. Okay. Then the friction F1 and then F2. So F1 and F2. So these are the two forces. Okay, now we will write equation. We have to find acceleration, so we will write equation along x. So equation along x direction. So which is x direction? This is x. This is x and this is y. Okay. So along x direction. So it will be M1g sin 30, M2g sin 30. Okay, these are the two forces down the incline, minus friction upward minus friction upward F1 F2 equal to M combined hai. They are combined, so M1 M2 into A. Okay, so M1g by 2 plus M2g by 2 minus how much will be friction? So friction is mu times normal. So mu 1 normal 1 minus mu 2 normal 2 equal to M1 plus M2A. So if we write this M1g, so we can put the values. So M1 is 2 kg into 10 by 2, 4 kg into 10 by 2, mu1 and normal. So normal will be mg cos 30 along the on the incline. The normal is mg cos 30. So mu1 m1g cos 30 degree, mu2 m2g cos 30, and then we can write m1 plus m2a. So next step we can write 10 and 20, 30. We have got then mu1. How much is mu1? mu1 is 0.2. 0.2. How much is m1? That is 2 kg. G is 10 cos 30 is root 3 by 2 minus how much is mu2? 0.3 into m2 is 4 into g is 10 root 3 by 2 and 2 plus 4 into a. So if you solve it, 30 minus it is 0.2, so that is 2 root 3, 2 root 3, and it will be 2. So it is 2 into 0.3, 2 root 3. This is 0.3 into 20 into 0.3. So 6 root 3 equal to 6a. So a will be equal to 30 minus 8 root 3 divided by 6. Okay. So in this way, this is the acceleration. Now this is the acceleration for the first part. In second part, if you see whatever we get, we can solve it and we can find whatever value we have. In second part, you can see that mu1 is more now. The first object is rougher now. Second object is smoother. The lower object is smoother. First one is rougher. So what will happen? They will separate now. They will separate. The lower object will slide faster and upper object will remain slower. So in second part, if you see part B, the acceleration of 1 means 2 kg. That will be direct formula we can apply. Because they are separated, we can directly use a formula, single, separately. So G sin theta minus mu1 cos theta. So G is 10, sin theta is 30 degree, minus mu1 is first, mu1 is 0.3. So 0.3 into cos theta is root 3 by 2. So whatever we get, we have 5, 1 minus 0.3 root 3. This is the first acceleration of a 2 kg block. Similarly, for 4 kg block, we can write G sin theta minus mu2 cos theta. So G is 10, sin theta is half, mu2 is how much? Second object is having 0.2, cos theta is root 3 by 2. So we will have 5, 1 minus 0.2 root 3. So this is the acceleration for second part for 2 objects. This is for 4 kg block. Okay. So in this way we can find in first part they have to consider together, and in second part they can be considered separately because they are sliding away. And one more thing in first part we have to see that if they are considered together, the forces are, see, in forces in both cases are same. But in first case, there is one more force. In first case, if you see, if you consider the two objects separately, if you consider suppose only for first case, if you consider only 2 kg object, so why should it have less acceleration than this value? This is the value whatever we have got for separate separate accelerations. What we have got, why it should have less value? It should have some extra force to manage that. So mg is downward and normal is like this, friction is like this, and there will be a reaction force between the two objects. In first case, since these two are in contact, the reaction force will also be, but reaction force is internal force, no need to find that. So reaction force will be acting here. That reaction force is decreasing the acceleration of 2 kg object in first case, and the same reaction force is increasing the acceleration of 4 kg actually. So they are now they are having the same acceleration. If they were not in contact, the reaction force would not have acted, and the 2 kg object would have got larger acceleration, while 4 kg would have got lesser acceleration. Now, because of this extra force R between them, the 2 kg which was having larger acceleration will have the decreased acceleration, and the same R will increase the acceleration of 4 kg. So finally, in combined motion, they will have the same acceleration. Okay. So this reaction force is a thing which is balancing the two things, which is making the two accelerations equal. Okay. So that was for first part only. In first part, we have reaction force also. In second part, no need to write reaction force. The two objects are separate. So they will move separately.